Hello guys, welcome back to our channel Automation is Future. So in our previous videos we have seen like flow control valves and their working. So in this video this is a continuation of working of flow control valves, some of the flow control valves and pressure control valves. In simulation we'll try to connect the sequence of operation. So let us try to connect. So we are left with quick exhaust valve connection and at the same time pressure sequencing wall connection. So this is the connection which we will be using. So let us firstly analyze the connection. So in this we have a double acting cylinder in which where one side we had connected quick exhaust valve and the other side we had connected one way flow control valve. Okay, and whereas coming to pressure sequence valve, we are controlling single acting cylinders with the help of single one. In this what happens is this moves one after the other. So in quick exhaust valve what actually happens is when extending of the double acting cylinder happens normally, but while it is returning it happens in a faster way. This can be used for simple applications where extending of cylinder needs to happen slow and return needs to happen faster way. And then in pressure sequencing mode, uh, we would be taking two cylinders, forward action and backward action, where these two cylinders need to happen one after the other. One after the other. The first cylinder goes forward and the second one goes forward. So in this way, we will be making this to work. So let us try to connect this in the simulation. So I am just opening the software. So I have taken a double acting cylinder and compressor, an FRL unit, compressor and an FRL unit. And then we needed a 3 by 2 wall. Sorry, not the. Yeah. So let us. We needed a 5 by 2 wall as it is double acting cylinder. So I am going for a 5 by 2 wall. Okay. We needed quick exhaust wall and flow control wall. So I have taken flow control wall and I needed a quick exhaust valve also. I had taken a quick exhaust valve. From here, I will be connecting. For this, let me take push button, and on the other side, let me take spring return. I am taking push button with latch, and on the other side, I have taken a spring. From 4, I will connect to quick exhaust. From quick exhaust to cylinder. From cylinder to my one-way flow control valve. Let me rotate it. So yeah, in this way we'll be connecting. Now let us see the simulation. So when I press the push button, cylinder moves forward. When I release the push button, cylinder moves backward. Sorry guys, we had connected the wrong connection. The previous connection was the correct one. Yeah. this is the correct connection. So let us set the opening level to 15% and quick exhaust valve. So when I forward is slower and backward is faster. So what actually quick exhaust valve does here is whatever the air flowing, it will release from this component, and at the same time what it will do is whatever the extra air present, it will make it to move from this silencer also, it will release into the atmosphere. So as a result, quick exhaust valve can be placed wherever faster movement or faster escape of air is wanted to happen. There we will be using quick exhaust valves. So the next sequence of operation is pressure sequence valve, where we will be connecting two cylinders, cylinder A and cylinder B. For the first cylinder, what we will do is commonly we will be connecting, but for the second cylinder, we will be connecting a pressure sequence valve. Let us try that sequence also. So, firstly, what we will do is we will take two single acting cylinders. I wanted compressed air supply, so I am taking compressed air supply and FRL unit. I wanted a 3 by 2 wall for controlling this single acting cylinder. So I have taken a 3 by 2 wall, and then we wanted a flow control wall. Let us rotate it into 180 degrees. Sorry, not needed for this. So let me connect from compressor to FRL, FRL to 3 by 2, 3 by 2 to flow control wall, and flow control wall to this one. Okay, and then we needed a pressure sequencing wall. So here I am unable to this. So what I can do is I will go for insert, find symbol. Here I will type as pressure sequence wall in pneumatic wall groups. So my component has got popped up. Okay, for one I will connect my pressure at the pressure supply. From two I will connect it to the this one. Okay, and we'll take one extra connection from whatever the air going into the cylinder. So just it is showing normal warnings. So for this 3 by 2 we wanted an activation, so I am taking a normal push button with spring return, and when we start the simulation, when I press, first cylinder has moved forward. Yeah, sorry, I think this connection got not connected. We'll try to connect it again. Yeah, forward and backward. Now we need to set the sequencing. I am setting this at lower. This connection also, I think it has not been connected. Yeah, it is showing the same thing. Let us try to connect it. Yeah, now it got connected. Now you can see both the cylinders are moving simultaneously. Now if I set the pressure bar to a higher range, what happens? The second cylinder doesn't start until the pressure is reaching at this pressure sequence wall. After reaching particular amount of pressure, then it will move. So let us try to set it at some 3 bar. Now you can see. So 3 bar is also making it to happen same time. Let it set at 5 bar. Now you can see there is a little bit delay. Now let us set it at 6 bar. Here we can see the first one has moved. The second one is not moving. So if I set air pressure at compressor at some 10 bar, now this will starts to move. Now you can see the first cylinder is moving first, and then the second one. When I release, both are coming at the same time. So you can see first cylinder forward, second cylinder forward, and then here you can see first one forward, and in the next step, second one will also move forward. In this way, we use pressure sequence valve. So that's it, guys. Thank you for watching my video. Automation is future. Don't forget to like, share, and subscribe to Automation is future. Thank you, guys.